Good morning. Now we are going to start our new topic, and that is Castigliano's second theorem. We all are aware about the Castigliano's first theorem, and in that case, we have studied about the how to find out slope and deflection for the determinate beams and determinate frames. Now, in the Castigliano's second theorem, we are going to analyze the indeterminate structures like indeterminate beams, continuous beam, propped cantilever beam, fixed beam, and indeterminate frames. So, for the analysis of indeterminate structure, we are taking total consideration of the Castigliano's first theorem. Based on that, we are analyze the indeterminate structures and their shear force and bending moment diagram. So let's start with one example, and that is determine the reactions at the support and draw shear force and bending moment diagram for the beam shown in the figure below. In this case, we have one propped cantilever beam and which is loaded by 60 kilonewton load at 3 meters from left hand fixed support and 1 meter from right hand simple support. So first of all, this beam is indeterminate, that we know, but we have to find out the SI, and that is 1. So we have 1 degree of freedom for the beam. So we have to take one redundancy, and it will gives us the another equation. We know that we have 3 equations, that is sigma h0, sigma v0, sigma m0, but here we need 4 conditions for the analyze this beam. So we have to take another one condition extra. Beam is indeterminate at first degree. Select VB as redundant. We are going to take VB as a redundant. So our beam will be cantilever. Now, if this is cantilever, then we have all the idea about the deflection. And what we are going to do, we are considering that deflection at B is 0. That is our extra condition for this beam. So for that, first we have to take segment, origin, limit, mx and del mx upon del VB, because we are going to take condition at B, deflection at B is 0. That's why we are taking VB over here. Now BC and CA, origin B, origin C, limit 0 to 1, 0 to 3. Here VB into x, and here VB into x plus 1 minus 16 into x. This mx is frequently used by us in our Castigliano's first theorem. So the same thing is done over here. The del mx upon del VB, that is x and x plus 1. Now this is our condition, and what we are going to consider, that here vertical deflection at B point is 0. So 1 upon Ei integration 0 to L mx del mx upon del VB into dx is equal to 0. So from this condition we will get our one unknown, that is VB. Once we will get VB, then after we can finding out all other reactions. So put up this value, multiplication of these two, and it is 0. So 1 upon EI integration 0 to 1 VB into x square dx plus 1 upon EI VB into x plus VB minus 16 into x plus 1 into dx is equal to 0. Again multiplication of these two, it will 1 upon EI integration 0 to 1 VB into x square into dx plus 1 upon EI integration 0 to 3 VB x square plus VBX minus 16x square plus VBX plus VB minus 16 into x into dx is equal to 0. Now this is the mathematical step and we know how it works. Now integration of that value is gives us VB into x cube upon 3 limit 0 to 1. Here VB x cube by 3 plus VB x square by 2 minus 16x cube by 3 plus VB x square by 2 plus VB x minus 16x square by 2 and limit 0 to 3. Now put this value in this equation. So we will get VB upon 3 EI plus 1 upon EI 9 VB plus 4.5 VB minus 144 plus 4.5 VB again 3 VB and minus 72 after putting the value of 3 in x, and we will get something this value. So another step, that is this is the constant VB upon 3 EI and summation of this all the value, that is 21 VB upon EI is equal to 216. It will be moved towards the right. So VB from this equation, that is 10.125 kilonewton. So now we have the unknown reaction VB is this one. Now reaction at A, that is VA is equal to VA plus VB is equal to 16. So VA is equal to 5.875 kilonewton. This is simply sigma V is equal to 0. So we will get this value. Now we have these two reactions. So moment at C, that is 10.125 into 1, it will give us the moment at C, and moment at A, that is 10.125 into 4 minus 16 into 3, so it is minus 7.5. Now we have all moment, we have all reactions, so we can draw the shear force diagram, that is VA is 5.875, it gives upward and it will move upward. So it is something like this. This is constant and downward value, that is 16. So it is 10.125 and here 10.125, it will upward. So this is our shear force diagram, plus and minus. Now the next thing, that is bending moment diagram, and here we have the bending moment at A, that is anti-clockwise 7.5, so it will in the direction of negative, and at C it is 10.125, so it is positive, so it will take upward. Now connect this value and the moment at B, that is 0, we know that. So here the moment is 0 over here, so we have to finding out this distance, that is called point of contraflexure. So we have to finding out point of contraflexure, and it can finding out by us with equal triangle method. So what is done over here? X upon 7.5 is equal to 3 minus x upon 10.125. We know that, and we have studied this method number of times in SA1 and MOS also. So from here we can get the value of this x multiplication, cross multiplication of these two value. So we will get something like this. Now x is equal to 22.5 upon 17.625. So here we can get the value of this x as a 1.276 meter. So dear student, this is the simplest method for analyze the indeterminate structures with the help of Castigliano's second theorem. But for that we have total idea about the Castigliano's first theorem. Clear everybody? Now this is the prop cantilever beam, but if there is continuous beam, then what will done over there? Let's start. Find the reactions at support and draw shear force and bending moment diagram using Castigliano's second theorem. This is our continuous beam with fixed at D, simple at B, and again simple at B. So in this case, the 60 kilonewton force is acting at the center of BD span, that is C point, and UDL at AB. Now first what we are going to do, we have to finding out the SI, and that SI is 3, 2, 1, total 5, but there is no horizontal force, so we can remove the horizontal reaction, that is HD. So here we have total 4 unknown and the condition is 2, so we will get 2 redundancy. Now beam is indeterminate at second degree, so we have to take VA and VB as redundant, so it will make our beam cantilever. Clear? Now for that we have to make the table, that is segment, origin, limit, mx, del mx upon del VA, del mx upon del VB. Here AB, origin is A, limit 0 to 6, VA into x minus 10x square by 2. Here we have 2 unknown, that's why we have to take these two things for the determination. So del mx upon del VA, that is x, but here it is 0. B to C, origin is B, limit 0 to 2, so VA into x plus 6 minus plus VB into x. So here VA and VB both are there, minus 16 to x plus 3. So differentiation with respect to VA, that is x plus C, and here it is x. For CD span, origin is C, limit 0 to 3, VA into 9 plus x or x plus 9, whatever you can do, plus VB into x plus 3 minus 16 to x plus 1 minus 16 to x. So here we have these two differentiation. Now we know that at every support the deflection is 0, so at A the support is there, so deflection is 0 over there, so we can take condition, that is delta VA is equal to 0. Now multiplication of these two, this and this, for every we can put the equation over here. So what we will get, 1 upon A integration 0 to L mx del mx upon del VA into dx is 0. So put that value 1 upon EI in the bracket 0 to 6 VA into x square minus 5 x cube into dx plus 0 to 3. For these two multiplication, VA into x plus 6 whole square plus VB into x plus 6 minus 16 to x plus 3 into x plus 6 into dx plus integration 0 to 3. For third one, VA into 9 plus x square plus VB into x plus 3 into x plus 9 minus 60 into x plus 6 into x plus 9 minus 60 into x plus 9 into dx. This is the longest equation. So we have to solve this equation, multiply of all the value, so we will get something like this. Now integrate that values with respect to x. So we will get VA into x cube upon 3 minus 5 into x raised to 4 by 4 integration 0 to 6, that is limit. Again for the second one and again for the third one. In this case you have to take accuracy in the calculation, otherwise you can make smallest mistake, the answer is changed, right? Now from the analysis of this we can get one equation, that is 576 VA plus 180 VB is equal to 25,110. This is our first equation for the first condition. Now second condition, that is deflection at B point also 0. This is our second condition, and we know that we have two redundant. We must have two conditions for that. So in this case 1 upon A integration 0 to L mx del mx upon del V into dx is equal to 0. Again multiply that value mx into del VB and we will get something this much equation, and that is equal to 0. Now again simplify this equation, multiply with all VA and VB, and after putting the value of all the in x, so we will get 180 VA plus 72 VB is equal to 8910. This is our second equation. Clear? Now from these two equations we can get two unknown, that is VA and VB, and after getting that we can finding out VD, total load minus VA plus VB. So we will get VD as a 30 kilonewton. So we have these three reactions. From these three equations we can get the shear force diagram. As you know, here 30 kilonewton, it going to upward, so we will going to upward, and here to here, that is 30 minus 60 means minus 30, here minus 67.5, the minus 30 plus 37.5 minus 60, so it will incline line, that is 22.5, and it will upward 22.5. So from this we can get the shear force diagram. Now for the bending moment diagram we must have the bending moment value. So we have to finding out the moment at A, that is 0, moment at B, this is 22.5 into 6 minus 10 into 6 into 3, so we will get moment at D, same way moment at C, same way moment at B. We can finding out all the moments. Clear? So that moments, that is A, at A 0, at B that is minus 45, at C it is plus 45, and at D it is also 45, that we can get directly from that value. So now point of contraflexure and the value that is maximum bending moment is somewhere over here, so we can finding out the all the bending moments. So minus, that is downward, this is plus, this is minus, and from here it is curve. Now we can draw this bending moment diagram, and we have all the idea about how to draw the bending moment diagram for the continuous beam, and how to draw shear force diagram again for the continuous beam. So dear student, this is the basic things for the finding out the shear force and bending moment diagram using Castigliano's second theorem, and it is the simplest theorem totally based on first theorem, and we have the whole idea about the Castigliano's first theorem. Clear? Now we can analyze again the indeterminate frame also. In next lecture we are going to understand about the how to solve frame indeterminate frames using Castigliano's theorem. So this is the method that used in finding out the indeterminate structures like this. Okay, thank you everyone. Now onwards we are going to analyze the frames. Thank you so much.